Hello everyone, and in this video we are going to be looking at derivatives again and their rules, some rules of derivatives. In other videos I will derive these rules, I will show them mathematically, but those videos are not necessarily required to watch. They are more just showing you where the formulas come from. So let's get started. So some derivative notation is the derivative with respect to x of f of x equals f prime of x. So that d over dx notation is the derivative with respect to x. That's how that's pronounced. And then another way is the derivative of y with respect to x equals y prime. Another way that's pronounced is dy dx equals y prime. So that's just some derivative notation I wanted to show you. That'll be used more often now. Now the first couple rules are the derivative of a constant is 0. Always true. So the derivative of 7 equals 0. Any number, any constant right there, derivative of any constant is 0. Why is that true? Because we will prove it in the derivation video, but also if we graph it, I'm just going to mark it with a dashed line. Let's call that graph y equals c. Notice how in the other video we discussed how derivatives measure rates of change. Well, in this graph, there is no rate of change. No matter what x value I plug in, the y value doesn't change. So y does not change for a constant. So that's why it's 0. Now the sum and difference rule is the derivative of f of x plus or minus g of x equals f prime of x plus or minus g prime of x. So we take the derivative of each term. That's what that means with the sum and difference rule. Pretty self-explanatory as well as with the constant rule. And then the power rule is the derivative with respect to x of x to the n, where n is a real number, equals nx to the n minus 1. So you take the exponent, drag it down, and then subtract 1. So if I had the derivative with respect to x of x to the 5th, this equals 5x to the 5 minus 1 is 4. Pretty basic rules. I didn't want to go too crazy for the first video. We're just showing a couple basic rules. Now with some examples, we got the derivative with respect to x of 5. That's a constant. 5 is a constant, so that derivative is 0. Same with this one. The derivative with respect to x of 0. It doesn't matter whether it's 0 or another constant. Derivative of a constant, always 0. Doesn't matter. Now the next example, we have the derivative with respect to x of 4x to the 7th plus 7x. So by the sum and difference rule, we can take the derivative of each term. So we're going to take the derivative of 4x to the 7th and 7x. So I'll just write it like this. Plus. So with the power rule, I'm going to drag this exponent down and subtract 1. So this equals 7 times 4 x to the 6 plus. Now, when you have the derivative of, let's say, kx with respect to x, that's always going to equal k. It's always going to be the thing in front of the x, in front of the variable, because by the power rule, we can say x to the 1, the derivative of that is 1x to the 1 minus 1 is 0. This will equal 1. And then 1 times k is k, and k is a constant. So the power rule is used there, but just so it's more obvious to you, if there's something in front of the x variable, that the derivative will be that thing in front. So this is 7. And then 28 is 7 times 4, x to the 6 plus 7. So that's the derivative. And I'm going to label these as f prime of x, just so we can get used to all sorts of notation. Maybe this isn't a function that's called f. Maybe it's g or h or another function, but I'll just call it f. Okay. Now we have the next problem. I'm not going to write out the derivative of each term. I'm just going to take the derivative. So 15x squared, the exponent comes down and we subtract 1. So it's 30x plus x to the 1. So the 1 comes down and we subtract 1. So it's 1x to the 1 minus 1 is 0. X to the 0. So this is plus 12. And then minus 0. So because negative 3 is a constant, so that's f prime. Now, let's get to some more complicated ones. There are very few complicated derivatives with these rules, but I will go over a few. So you see in this next example, you have e. You have an e there. Remember from another math class, maybe pre-calculus, that e is just a number. It's approximately 2.718. It's just a number. So for this example, you're also going to take the power rule. So you're going to take the e down, and then, and you're going to take the e down, and then you're going to have e minus 1 for the exponent. Don't write 1.718. That's technically wrong. Just leave it as e to the x to the e minus 1. And then plus 0, so because 7 is a constant, so this equals f prime of x. Yeah, just leave it as 2e x to the e minus 1, because the e comes down, and then you're going to subtract 1 from the exponent, because it's just a number. Now with this example, we have the derivative with respect to x of pi cubed. Now, pi cubed is just a constant, right? A lot of students will say this equals 3 pi squared by the power rule, but it doesn't. So, since there's no x's here, you're just taking the derivative of a constant, really. There's no x's there. Pi cubed is just pi times pi times pi. Those are constants. So this is 0. There's no x's going on, so you can't really take the derivative of anything else. It's just a constant. So the derivative with respect to x of pi cubed is 0. Now for this example, you may think, oh, we need to use another rule or something like that. But remember for exponent properties, you can flip the exponent up here, but just make it negative from algebra. So this is the derivative with respect to x of x to the negative 2. And then you apply the power rule. So you have to rewrite it first as, because 1 over x squared equals x to the negative 2, and then you apply the power rule. So this equals negative 2x to the negative 2 minus 1. This equals negative 2x to the negative third. Now, when the derivatives get really, really complicated, when we have like product rule, chain rule, quotient rule, other kind of rules, you really don't have to simplify your derivatives. This one's pretty easy to simplify, like negative 2 over x cubed. But for other complicated derivatives, you're really not going to simplify. So if you want to leave the answer as this, that should be okay. But this is that would be the simplified version. I'll write f prime of x for the rest of these. Okay, that should be it for this video. We are going to be learning other rules in later videos for derivatives. And then I will be posting other videos on how to derive these rules, just to quickly show you. But if you have any questions, please leave them in the comments, and thanks for watching.